Champions League is played in conjunction with
Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam, Doktor.
Selamat sejahtera.
Selamat sejahtera, Doktor.
Oh ya, dia Discord dah.
Dah makan.
Aku Discord.
Dah makan, Doktor.
Dah makan.
Dah.
Makan apa?
Makan Maggi, Doktor.
Astaghfirullahalazim. Makan Maggi je. Kesian.
Dia dah lain dia Doktor.
Okay, bismillahirrahmanirrahim. Assalamualaikum and selamat sejahtera. So we continue our last subtopic of chapter 2, which is the modeling of electromechanical system. So when we talk about electromechanical system, it consists of two disciplines, which is the electrical and mechanical components that generates mechanical output by an electrical input, that is motor. So is a motor lah, is a DC motor. So the input for the this DC motor is EA, which is known as electromotive force, and the output is theta M. Theta M is the angular displacement of the motor. We know that this is the motor, okay, and it have a shaft, okay, and this shaft is rotating, okay. The shaft is rotating, and usually at this shaft, okay, at this shaft, it attach okay. It attached with a disc, okay. So this is the disc, and this is the shaft that rotate, okay. And at this disc, we know that this also will rotate, okay, according to the shaft directions. So when we are using the disc, we know that a disc is a circle, and circle which have a 0 degree, 90 degree, 180 degree, 270 degree, and then 360, or which is equal to 0 degrees. So these degrees is reflected by the angular displacement, or we know as a theta M. Okay, so this is the
Induction motor.
yes, no, is a DC motor, which consists of a rotor and a stator. Okay, so this is the shaft that I tell you. Okay, and there is some gear on it. Okay, so inside the rotor and the stator is the winding, is a copper winding. Okay, so this copper winding will supply the EA, okay, well, voltage, electromotive force, okay, the supply to the armature circuit, which is shown here. So this is the power supply of the armature circuit of the motor, the resistance and the inductance. Okay, and the rotor have their electromotive force, which is BB, and rotate accordingly to the torque of the rotor. Okay, top tu is daya kilas lah. Okay, it rotate the shaft with the angular displacement theta m, and on top of that we have a fixed field circuit, okay, which will induce the rotor to rotate accordingly. So armature circuit, the current that in the armature circuit is known as IA, okay, armature current. Passes through magnetic field and produce a force, electromotive force, which is using the Fleming's left hand rule, which is shown here. Okay, so we have 3 fingers. The this one, the first finger is the motions or the thrust, and the second finger is the field, and the middle finger or the third finger is the current that flow to the circuit. Okay, so the resulting torque turns the rotor, okay, rotating the motor towards the clockwise one. And the fixed circuit, okay, here is to develop the magnetic field B by stationary permanent magnet. So since the current carrying armature is rotating in the magnetic field, so its electromotive force or BB or EMF is proportional to the angular velocity. Okay, so therefore kita boleh tuliskan, can write a relationship where VB is equal to KB is equal to theta m dot. Okay, so this one is theta m dot, or we can write it as d theta m dt. Okay, so is the velocity lah, differential of angular displacement. So you will get a velocity displacement. Then taking the Laplace transform on the left and on the right of the equation 1, so we will get VBS is equal to KBS theta MS. Okay, equation 2. So by applying Kirchhoff current law, okay, Kirchhoff voltage law in the armature circuit, which is here. Okay, so this is armature circuit. So when you apply Kirchhoff voltage law, so EA is equal to IA RA plus LA DIA DT plus VB. Okay, plus VB. So that's why we will get equations of the KVL around the armature circuit as shown here. Okay, VB plus LA SIA plus RAIA. Okay, so this one is Laplace already, which is equal to the voltage supply EA. So we know that torque developed by the motor, which is TM, is proportional to the armature current. Okay, EM and IA is proportional. So therefore, EM is equal to KTIA, where KT is the constant. Okay, this one KB also constant. Okay, or we can write it as IA is equal to 1 over KT multiplied by TM. Okay, so we have 1, 2, 3, 4 main equations. So we substitute equation 2 and equation 4 into equation 3. So we will get equation number 5, which is RA plus LA S multiplied by TM divided by KT, the constant, plus the KB as theta M, which is equal to EA. So since the shaft will rotate, so therefore we sometimes put equivalent mechanical loading on the motor. So the mechanical loading of the motor can be represented by this equation, Newtonian equation. EM is equal to JMS square initial plus DMS, which is the viscous damper, multiplied by angular displacement. And equation 6, we substitute into equation 5. So now the equation become bigger because we already include theta m, EM, which is represented by equation 7. So in amateur circuit, usually the inductance LA is very, very small. Okay, that's why we can ignore the value of LA. So when LA is equal to 0, this one is 0. So this equation can be simplified. Okay, so it becomes K over S plus alpha. Okay, where alpha is represented by this bracket, and K is represented by this constant KT divided by RA divided by JM. So usually in the circuits, all KT, RA, and JM is fixed already by the motor manufacturer. So come back to this equation. Okay, so this equation is the transfer function of the DC motor. Okay, theta M divided by EA. So theta M is the angular displacement and EA is the voltage supply or the input. So when we have a rotational mechanical load, which is shown here, okay, so this is the shaft, this is the disc with gear, and this one is the disc with gear as well. And the load is have an inertia JL and viscosity damper DL. So N1 is the number of teeth, okay, number of teeth of gear 1, and this one is number of teeth for gear 2. Okay, so of course it will rotate, so one clockwise, the other one is anti-clockwise because of the gear factor, and therefore we can write the equation for the JM, okay, which is equals to JA plus JL, okay, to represent the motor load, okay, and the viscosity damper is equals to dA of the motor plus the load, which is DL, plus ratio of the gear N1 over N2 square. So since we ignore the value of inductance LA, we can take the Laplace transform, okay, of the equations, which is shown here, right? This one. And the time domain equation is this one, is equivalent. Okay, the equivalent of the S domain. So this one is T domain. And this one is S domain. Or we can say as the frequency domain. We apply Laplace. Okay, I want to ask you something. From S to T, we use what? From S to T. Zulfika Muhammad. Zulfika Muhammad.
Yes, Prof.
From S to T, kita guna apa? What tools we use?
Inverse Laplace transform.
Inverse Laplace transform. From T to S,
Laplace transform.
Laplace transform. Okay, bagus. Oops, salah. Very good. So we continue. So the equations that we obtained just now, okay. So we simplify equations, okay, for Tm, right? So Tm, we derive Tm. So we got these equations, which is minus Kb plus K minus Kb Kt over Ra multiplied by omega m plus Kt over Ra Ea T. Okay, this is the input voltage. Okay, this is the frequency. Okay, omega m. Okay, at steady state. Okay, steady state ni adalah keadaan mantap. In Malay, we call it as keadaan mantap. So in steady state, the Tm is equals to minus Kb Kt over Ra omega m plus Kt over Ra multiplied by Ea. So we can plot this torque, okay, and this omega m, okay, the speed, okay, the d theta m over dt, okay, as shown here, okay, the speed, radians, okay. So you can plot it as EA1 and EA2, okay, where at this point the speed is 0, okay, where Tm is equal to Kt over Ra divided by Ea, and at this point at no load, okay, the T is equal to 0, so omega is equal to Ea over Kb. And from this graph, we can get a relationship which is Kt divided by Ra is equal to the torque, okay? When speed is 0, T stall tu maknanya dia it's not moving, okay? Static, okay? Over Ea. And Kb is equal to Ea over omega. Right. I want to ask you something. Siti Nur Syuhada.
Yes, saya.
Syuhada,
Ya.
what is the mathematical equation for this curve?
Y sama mx tambah c. Yang tu ke?
Ya, yang ni?
Y
Y.
sama mx
Hmm.
tambah c. Yang tu ke?
Tak dengar. Hello? Line tak bagus. So, Sharifah Khairunisa.
Doktor,
What is the equation for this straight line?
Tm is equal to T stall over W W no load plus T stall.
Alah. Nurul Shakila,
Yes, Doktor.
what is the equation for this straight line? The one that I show you here.
Tm equal to KT over RA EA.
Alah. Y is equal to minus mx plus c. Okay. What is y? Y is the Tm. All right. Y axis equal to minus m. What is x? X is omega m, the speed, kan? Plus c. Okay. Nurul Nabila. Nurul Nabila. Tak datang. Tak datang. Tak datang. Nurul Hidayah.
Yes, doctor.
What is the equation of the blue line? Ni,
Y.
ni equation ni kan?
Mm-hmm.
What is the value of m and c? What is m and
For
c?
for C sorry, untuk for the same line, doctor. Do you mean for the same line?
Yeah, they are same line.
For C is T stall.
C is T stall. T stall tu apa?
Mhm.
What is T stall?
T stall is not move. I mean,
The shaft is not moving, static.
mm,
Okay.
mhm.
M,
M is gradient. EA
M apa? What is M?
M is gradient EA1 maybe, I think.
D apa?
EA1 maybe. I'm not
Maybe.
sure.
Yang betul kan? EM
E,
over
mm,
over D
D,
omega.
like,
Okay.
mm,
So since the graph is like this, so it's a negative, negative slope. Okay.
mm.
Oh, belum masuk lab eh? Lab belum masuk. Right. So we are giving you an examples here. Find the transfer functions theta L divided by EA. So EA is the input, which is here. Okay. Theta L is the load angular displacement. Okay. So what is the ratio of N1 over N2? Aisha Akram.
Yes, Prof. Ratio
N1 over N2.
N1 over N2. So, bagi je lah kan. Dapat 0.1.
Huh?
0.1.
0.1. Okay.
Pada Prof, just now, for the T-stall, is it stop moving or start moving?
Speed
I'm
zero.
sorry.
Omega M
Zero.
zero. Speed zero.
Okay, thank you so much.
Aisha. Oh, Aisha. Aisha.
Aisyah mana, Prof?
Aisha Akram.
Lagi sekali. Okay.
Since you tanya T stall, so what is the value of T stall in this example?
500.
What is the value of the torque at 50 radian per second?
0.
0. Okay. So you must understand this graph. Okay.
Okay.
So you must understand this graph. Graph is given. Okay. And then what is the viscosity damper for load? What is the value of viscosity damper for load? By Sarah.
Yes, doctor. 800.
800. 800. Okay, what is the initial value of the motor? Sarah. Look at my finger.
5.
5 kilogram meter square. Oh, dia tu. Ni. Tidur ke? Depan mata je. Najwa. Nur Najwa.
Yes, doctor.
What is the value of viscosity damper of the motor?
2 Newton meter second per radian.
What is the value of inertia of the load?
700 kilogram meter square.
What is the value of resistance, armature resistance? What is the value? Not
RA tu ke?
not given. The answer
Okay.
is not given. Gabra.
Okay.
Semua ada kat situ. Okay, are you ready? So we use the equations. Okay, JM, the total. Okay, total. Okay, the total M is the motor plus the load. Okay, using the equation just now, which is equal to 12. Then viscosity damper dA plus dL, and 1 over n2 square, so it's equal to 10. JM 12, dm 10. Find the electrical constant KT over RA and KB. So since the T stall is 500 and omega no load is 50, okay, and plus EA, positive EA, which is the supply, is equal to 100. By using the formula here, okay, so KT over RA over T stall over EA, we get 5, and KB is equal to EA divided by omega no load is equal to 2. Insert the equations to the standard transfer functions, where inductance is 0. So we get 0.417 over S plus S 1.667. Okay, but theta M is equal to TL 1000 divided by 100, meaning that's 10 times of theta L. So replace the theta N with the theta L, so you will get 0.0417 over S plus 1.667. This is the transfer functions. Very straightforward. Okay. Sample number 2. So sample number 2, we have a amateur circuit, inductor 0. Okay. The motor inertia 5. The viscosity of the motor is 6. Okay. And the inertia of the load is 18, and the viscosity damper is 8. Okay. Ahmad Fakhrul Razi. Ahmad Fakhrul Razi. Tak tahu. Ahmad Zulizat. Ahmad Zulizat. Tak datang. Aisyah Syahira.
Yes, Prof.
What is the ratio of the gear?
Ratio of the gear 50 over 150.
Equal to? 0 point?
0.333.
3333333.
Yes.
Okay. So it's given graph here. Okay. 100 T-stall and 150 for the omega M, right? So just as usual, so you split into amateur circuit, motor and loading, and find theta L over EA. Previously same like just now. Okay. So you just insert the value, put the value, and then you get the transfer functions. Okay. So you can see that here. Okay. The theta L is equal to 0.333 theta M. The ratio of the gear, kan? Then put inside, put here inside. Okay. So you obtain something like this. Okay. What is the roots of these transfer functions? The roots value. Azri Rukaini. Azri Rukaini. Azri Rukaini. Azri. Datang. Azri Rukaini. Datang, Herman, Benedict Herman. Benedict Herman.
Yes, doctor.
Can you hear me?
Yes.
Okay. Do you hear me?
Yes.
What is the roots of the equations, transfer functions?
S.
S plus 38 over 21. So, Herman,
S equals to 0 or S equals to negative 38 over 21.
berapa?
38 over 1.80952381.
Oh, long.
Panjang.
Two decimal point. Cukup lah, bah.
Okay.
Panjang banget.
Okay, doctor.
Okay. Okay, some skill assessment for you. Okay. Right. So I think the same thing, right? Same things. End of chapter 2. Okay. So okay.
Yes, doctor.
Soalan. Okay.
Tak ada.
Ada.
Wait.
Tak ada.
Tak ada.
Okay. So if there is no question, I have question for you.
Okay.
This electromechanical system or DC motor amateur control can be applied in the car, automobile. Can you name a few applications of DC motor in automobile?
DC motor in automobile. Changing gear? What about changing gear in car?
Alah, itu pakai gear. Changing gear, manual. I mean DC motor.
DC motor.
Rita, tolong dia.
Yes, doctor.
Where you can apply DC motor in a car or automobile?
Induction motor. AC induction motor.
DC motor, DC.
Oh.
Induction motor tu AC motor. DC motor. DC tu apa? Rita, DC tu apa?
Direct current.
AC?
Alternating current.
AC-DC?
AC/DC.
AC-DC apa?
Alternating current, direct current.
Itu komponen rock.
Oh, is it? So for DC motor in car, is it electric cars, doctor?
No,
For electric? No.
no.
Radio, doktor?
Tak boleh, salah. No.
Brush DC motor.
Wiper.
Wiper.
Oh, wiper.
Wiper.
Okay,
DC
doctor.
motor. What else?
Radio?
Tak boleh.
Uh,
No radio. Radiator.
radiator.
Radiator, cooling fan. DC motor. Okay.
Okay, doctor.
Azri Rukaini. Tak ada. Farid Rizwan.
Here's the contact info for Hazira.
When we apply DC motor in the car at the radiator part, the engine part, okay, can you explain what is the function of DC motor in the radiator part of a car? Kita tahu radiator, inside radiator there is the water, okay? So when the engine on, so the water in the radiator will become hot, okay? And this water will moving around the engine, okay? To cool the engine, sejukkan, okay? To cool down the engine. But at certain temperature, when the temperature is hot, this water, this hot water need to be cooled down by a cooling fan. So the DC motor at the radiator part will cool down the hot water in the radiator for engine cooling. Faham tak? Can you understand?
Faham yang guna coolant tu ke doktor? Coolant liquid instead of water. Okay.
Coolant tu is a chemical liquid which is added to the water to accelerate the cooling down. Okay. Sometimes the color is blue, sometimes the color is green. Okay.
So in case the boiling point, doctor.
Tak sampai boiling point. Okay. If no question, we go to the tutorial. Okay.
Doctor, I have a question.
Yes.
For the EA just now, is it fixed for every question?
No, it depends on the questions.
So we have to derive ourselves.
The value. The value EA is given. EA is given. The value of power supply.
Oh, okay, doctor. Thank you, doctor.
Okay. Bakesh, can you read question 1, please?
Yes, doctor.
Question
Find the transfer function GS equal to V naught S over VIS for the electrical network shown in figure question 2, where VIT and V naught T are the input and output voltages respectively.
So what is the input, Balkis?
The input is VIT.
VIT, VI of T.
VI of T.
How many components in the circuit?
Passive, passive or all. 1, 2, 3, 4, 5, 6.
6. How many resistance?
3.
How many capacitance?
1.
How many inductance?
1.
Okay. Oh. Okay. So we're going to find the transfer function. Okay, can you see? Right. Daniel. Daniel, Aiman. Ashraf.
Yes, bro.
What is the equation for loop 1?
Equation for the loop 1, voltage or current?
KVL lah. KVL lah. KVL lah.
KVL. IA R2 ohm plus
VI over S equal to
IA 2 ohm
2 IES
yeah,
plus
with 6 IA minus IB.
Okay, 6 IA
minus IB.
Minus IB. Okay. Plus
capacity to IA.
to S, inductance to S.
Oh,
Inductance
sorry.
Inductance LS kan?
Yeah.
Okay. So IA minus IB. Okay.
Yes.
Faham tak? Faham tak equation ni?
Faham, Prof.
Ashraf off.
Oh.
Okay. So you open these equations. 2IA plus 6I AS minus 6 plus 2SIA okay. Then you rearrange the equations. 2S plus 8 minus 2S IB equal to equation 1. Okay. Itu adalah loop 1. Loop 1. Loop 2. Aisyah Akram. Loop 2. Loop 2.
Six IB minus IA.
Multiply by 6. Multiply by 6.
Multiply by 6.
Okay.
So
Plus.
then plus 3 plus 4 for IB.
2 Henry tu. 2 Henry.
Oh, 2 Henry. Plus 4 IB and then plus 2S IB.
Okay. Plus.
Okay. And then plus kejap doktor, saya rasa saya salah tengok soalan. Minta maaf.
Astaghfirullahaladzim. Wah, ni budak.
Sorry. Saya boleh okay, sorry. Okay, ulang balik. Okay. 6 IB minus IA plus 2S IB minus IA plus
Jap, tengah tulis. Okay, plus
4 IB and then capacitor saya terlupa doktor. 1/0.5 S. Okay. And then tu je. IB. Thank you, doktor. Thank you. Equal to V naught. 0.
V naught. Astaghfirullah. V naught. Ajaran sesat. 6 IBS plus 6 IES plus 2S IBS minus 2S IES plus 4 IBS plus 2/S IBS equal to 0. Question? Okay. Betul tak, Maisara? Maisara, betul tak?
Betul, doktor.
Then rearrange. Okay.
Excuse me, Prof. Saya nak tanya. I want to ask. Is it the mark will be given those who change the circuit into frequency domain circuit from time domain.
You can start with time domain, then you take Laplace transform. Okay, so you get the S, or you want to straight away go for the Laplace without time domain, also can, no problem.
Okay, so the last must be in the S domain, right?
Yeah.
Okay, thank you.
So we have a break for a while. Okay, boleh you continue. We have a break about 10 minutes.
Okay, doktor.
10 minutes break.
Okay, doktor.
Okay, doktor.
can't expect your team. When you're down and troubled and you need a helping hand and nothing, oh, nothing's going right. Close your eyes and think of me, and soon I will be there to brighten up even your darkest night. You just called up my name, and you know wherever I am, I'll come running. Oh yeah, babe, see you again. Winter, spring, summer, or fall, all you got to do is call, and I'll be there. Yeah, yeah, yeah. You got a friend. If the sky above you but you got a friend. People can be so cold. They'll hurt you and desert you. Well, they'll take your soul if you let them. Oh yeah, but don't you let them. You just call out my name, and you know wherever I am, I'll come running to see you again. Oh baby, don't you know about winter, spring, summer, or fall? Hey now, all you got to do is call. Lord, I'll be there, yes I will. You got a friend. You got a friend, yeah. Ain't it good to know you got a friend? Ain't it good to know you got a friend? Oh yeah, yeah, you got a friend.
Okay, can you hear me? Hello?
Yes,
Yes,
Prof.
doctor.
Sambung ah. Okay, so you have question 1 and question 2, correct? Hello? No.
Betul, Prof.
Yes, Prof.
So you create, rewrite. Okay. Balkis, help me.
Yes, doctor.
Help me. Matrix.
What's the number before, doctor? I didn't write it down.
Uish, tidur dah.
Two. Mana
Yes.
dah?
Ni.
2s plus 8.
Okay.
2s plus 6 and negative 2s plus 6 and negative minus negative s plus 6.
Okay.
IB is
BI. Kan, input.
yes, input.
Okay, question number 2.
6 wait, 6 IB 6 IB 6 IA negative 6 negative 2s
Minus 6 IA. Kan?
yes
IA. B-nya.
B is 4 plus 2s 4 2s plus 4 wait 4 plus 2 over 3 itu doktor 2 atau 2 over s plus 2s plus 4 10
Okay. Okay. Betul.
Betul.
Betul, eh? Rida Hadirah, betul ke ni? Rida
Ya,
Hadirah.
Prof. Ya. Betul.
Betul eh? Betul lah. Okay, so kita nak cari IB. Okay, so IBS adalah, so kita take this part then couplekan dengan this part. Okay. So it will be 2s minus 2s plus 6. Okay. Rida Hadirah ni apa?
Determinant.
Okay. So the delta tu is the determinant of the the whole thing. Okay. Okay. So we cross multiply. Okay. So what do you get? Izati.
Yes, Prof.
Simplify. Okay. And this part, yang ini. Apa? Aina?
Ya, Doktor.
Determinannya.
VIS
Okay.
2S plus 6.
Okay. Ya, negatif, positif kan?
Yes, Doktor.
Okay. But V naught apa? Kita nak cari V naught over VI kan? What is V naught? Aisyah Akram, what is V naught?
Minot.
Hmm.
Sekejap. Tak faham soalan tu.
V naught output kat circuit.
Oh, bina apa kat circuit. Dekat bahagian tu. Resistor. Empat for IBS
Okay.
over for
What?
IBS
Over?
only. No. I thought over VI. Okay.
Oh, IBS. Okay. IBS. Ini IB bukan I2. IB. Okay. IB Okay. So this IB, okay, will be insert here. Correct? Correct or not? Betul?
Yes, Doctor.
Yes, Prof.
Okay. Faham tak? Tahu tak?
Faham Doktor.
Okay. So second questions, tutorial. Balkis, again.
Second question. Find the transfer function GS equal to V naught of S over VI of S for the electrical network shown in figure question 2, where VI of T and V naught of T are the input and output voltages respectively.
So almost the same kan, tapi they have a different values, am I right? So which one is the different?
The position of capacitor and inductor,
Okay, lagi.
and also the position of V output.
Okay, so you still using the same concept. Kan?
Yes.
Still using the same concept. So therefore, Najwa, Atira, can you give me the loop one equations? Loop one equation. Datang. Hafiz Nazim. Hafiz Nazim.
Yes, Doctor.
Loop one, question 2.
Loop 1. VI equals to 2IA 2I1 plus 6I1 minus I2 plus 1 over 2S I1 minus I2
Plus two over S. Correct. Which one?
I2 ya Doktor?
Huh?
I2 ke?
I2, yeah. 2 per S. I1 minus I2.
I1 minus 0 equals 4 I2 plus 2S I2 plus 1 over 2S I2 minus I1 plus 6 I2 minus I1.
Itu apa? Loop 2. Loop 2 kan?
Ya?
Loop
I2.
2. Loop 2.
Yes, betul.
6 I2 minus I1 plus plus ni kan? Betul?
Yes, betul.
Rearrange. Dan Rita? Tolong saya, Bang.
Prof, share screen.
Yeah, I don't think you're sharing the screen.
Okay.
Sorry. Okay. Loop 1, loop 2 kan?
Hmm.
This one is system. Okay.
Sorry, Prof. I didn't get to write the number. So for the matrix 2I1, 2 plus 6 plus 2 over S. And then
2 per S plus 8
yeah.
plus 6 kan? Tolak. Okay. So we want to find V naught over VI kan? Okay. V naught-nya di ikut soalan. Okay. So you have to find I2. Okay. Find I2. So find I2. Okay. I2 is 2 over S plus 6, 0. Okay. So what is delta and Rita? And Rita? What is
Yeah.
delta? Delta.
Delta. We have to cross multiply the determinant.
Okay. Yeah.
So 2 over yeah.
So simplify. What do you get?
Wait, okay.
Okay. This one also cross multiply. All right. V naught sama dengan apa? Hafiz Daniel. Hafiz Daniel. V naught sama dengan apa? 2S I2. Okay. So masukkan I2 ke dalam. Lukman, Anwar. Lukman. Datang. Syafiq Yusof. Syafiq. Tak datang. Zainal Arif. Zainal Arif. Tak datang. Aisyah Soleha.
Yes, Prof.
What is the roots for the numerator?
0 and negative 1/3.
Negative. And denominator?
Negative 0.275
And
negative 2.725.
okay. So as zeros for denominator. Okay. Angku Izzat. Angku Izzat.
Yes, doctor.
Can you read what I wrote here?
Roots for number
Numerator.
numerator is
Known
known
as
as
zeros.
zeros. Root for denominator is known as poles.
Poles. Okay. So we can plot it as plane. This one is a real exists. This one is the imaginary exists. Okay. So the value is tadi berapa? Aisyah Soleha.
Yes.
Value tadi 0 and
Negative
negative
1/3. Oh.
Okay.
Yes.
And the value of the poles
Negative
minus
0.275.
2 and
Negative 2.725.
Jane. Okay. So the model consists of a numerator and denominator roots, which is referred by poles and zeros. Okay. So next questions. Question 3 also the same. So you use the same concept. Okay, use the same concept. So let's go to the one that I sent to you. Yeah, what's that? This one mechanical.
Can you go to the question?
Yeah.
Question 5, maybe?
No. I give you this one. Wait. Mechanical. Okay. Zakari? Brother Zakari?
Yes, doctor.
Yeah, can you read the question for me?
Okay. Figure Q3 shows translational mechanical system in which Ft is a force applied to the system. The variable x1t and x2t refer to linear displacement of the motion. Assume all initial conditions are zero. Obtain the transfer function.
Okay.
X2s over fs.
So you are given
So,
M1.
yeah.
Continue.
Yeah,
Continue.
so we given mass 1, 11 kg, and I can see it. I don't know.
Can you see? Can't see.
Yeah, I don't. I think it's no. Yeah.
Okay.
Yeah. Okay. FU1 is 2n S of m. F2 is 3n as S of m, and F3 is 4n S of m. Mass 2 is 13 kg. K1 is 5 Newton per meter, I guess. K2 is 6n of m. K3 is 7n of m. Yeah, and that's the picture of the question, I think.
All right. Thank you.
Okay.
So we begin with the mass M2. M2 first. Okay. What is the M2 punya force involved? Aisyah Akram. FT kan ni, F of T apa? Force kan, input force.
Mana Prof tulis ke?
Sorry. Okay. Force F of T on your right.
Yes.
Then what else? M2 x2 double dot dx2 dt square. What else? Spring K2 x2. Then K2 x2, they are the change of displacement. Okay, so K2 x1. Then the FV2. FV, the frictions. Okay, the frictions is FV2 is over here. Frictions, x2 dot. Then we have a opposite side of the x1, which is FV2 x1 dot. Okay. Then you create the force of equations from here. X2 double dot plus T2. X2 minus X1 plus FV2. FV2 is the frictions between M2 and M3. Which is X2 dot minus X1 dot. Equation. Okay, and then force for M2, sorry, M3. Sorry, M1, sorry, M1. Okay, So force of M1, the input force at M2. So M1, there is no force, but it involved from the input F of T. So we can draw the free body diagram. Okay. For X1, M1, X1 double dot, K2, X1. Then we have the opposite side of the K2 due to the X2. Sorry, this one no dot. K2, X1. Okay. Then you have a FV2. Okay, the frictions. X1 double dot. Then you have here FV2, X2 dot. And then you have a FV1, which is the damper near the M2. So I continue here. Okay, and plus the spring. Okay, plus the spring, you have 1, 2, 3 springs over there. Okay, so K1, X1, K2, X2. Okay, sorry, K2, X1. Sorry, not K2, K3. Okay, 3x1. Then lastly is the FV3. Okay, so FV3 is the frictions under M1. So another frictions, FV1 plus X1 dot. Okay, so you have a 1, 2, 3, 4, 5, 6, 7 on left and 2 on right. Okay, so you create the equations. And 2 X2 double dot plus K2 plus FV2 equation 1 zeros X1 double dot K2 plus FV2 X1 dot minus X2 dot plus FV1, the damper, plus the spring, plus the frictions of the M1. Okay. Question number 2. Then you Laplace equation 1 and 2. Okay, so use Fs M2 S square plus K2 plus FV2S X2S minus FV2 S plus K2 X1S. Okay, this is equation number 3. Then equation number 4 will be 0. Plus K1 FV, FV1 S plus FV2 S plus FV3 S X1 S minus FV2 S plus K2 X2 S equal to 0. Question number 4. Then you construct the matrices, rewrite in matrix form. Okay, X1, X2, F 0. So this one you insert all the values. Okay, all the values given. The M value, the M1, the M2, K1, K2. Okay, inside the given in the question, so we'll get minus 3S. So plus S square. Okay. So you want to find X2. Okay. Due to the fact that you want to find the X2 divided by Fn. So you have to find X2 first. So X2 macam tadi using RLC. Okay. Which is minus 3S minus 6. Delta is there. Okay, so you simplify this one. So delta, you will get 1 for 3S4. Okay, and then X2S. So you simplify this one. Okay, X2S. So you will get 11. Over delta. Okay, so quite long because we have two mesh and we have 1, 2, 3, 3 springs. 1, 2, 3, 3 damper. Actually, one damper, FV1, FV2, and FV3 is considered as frictions. So can I have the roots for this, Balkis? Roots for numerator?
Wait ya, doktor. Kira calculator jap. Negative 9 plus 3. Dia ada imaginary number.
Okay. Plus?
Plus 3, 79.
Plus 3, 79. Simplify lah.
Simplify.
Minus
Oh,
9 plus
kalau nak decimal, negative 0.41.
Negative.
Negative 0.41 plus J 1.21.
Yang ni
And the other one is
for
the same.
denominator.
Denominator. 1435. Oh, power of 4 itu doktor.
Power of 4.
Sekejap.
So you have to use this type of calculator.
Yes.
Can you see? Yang putih. You see this calculator?
Yes, doktor. 150. One four three 150 303
72
72
and 72.
72. Negative 0.067 and negative 0.67 juga, tapi ada imaginary number. Sekejap. Negative J 0.54.
Bisa tu?
Lagi satu negative 0.46.
Lagi satu.
Plus J 1.22.
Okay. So ada
Yes.
4 imaginary numbers lah.
Yes.
The 4 imaginary numbers. So the system is order of 4 lah. Because the highest order is 04. Is 4th order. Okay. So I think I stop here. Okay. So we will continue discussion on the tutorials inshallah on Monday for 1 hour. Then the next Wednesday we will go for the chapter 3. Is it okay?
Okay, Prof. Excuse me, Prof. I have a
Yeah.
question last. For the mechanical application, is it included in the test or only in final or both?
From the past session subjects, the test will be chapter 1, chapter 2, and chapter 3. Chapter 1, chapter 2, and chapter 3. Only one test.
Oh, so they basically just now the mechanical parts also include.
So RLC and mechanical is also included. So that's why we need more discussions in the next Monday. Okay. So
Okay, Prof.
you can try to do this during weekend. Question 3, 4, 5, and so on. Okay. And then we will discuss together. Betul tak? Okay.
Yes, Prof.
Tidur semua budak-budak ni, berdua ni, hujan-hujan ni, tidur je. Okay, is there any questions? Sakari? Hafiz?
Saya ada soalan regarding test. Ada any chance tak yang kita boleh tunda sebab hari yang sama tu ada juga test lain. Test lagi satu tu pukul 5 sampai 7. Test kita pukul 9 kan doktor. So gap dia 2 jam itu.
Subjek apa tu?
Subjek communication principle.
Dia agak jijik doktor kalau dua subjek berat on the same day.
Berat?
Kasihanilah otak kami doktor. Okay.
Actually, I don't have the power. The power is on the coordinator. We just follow the date. The date is set by Dr. Fatima. Okay. Anyway, I will inform her regarding basic communication principle.
Yes,
communication
Doctor.
principal.
Yes.
So I will inform them. How come they, siapa yang set dulu? Kita set dulu kan?
Tak sure lah.
Uh,
Tak sure siapa set dulu.
So I will inform them insyaAllah. Then I will update to you later. Okay, thank you very much. Bismillah.
Okay, thank you, Prof.
Allah. Thank you very much.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.